Are you facing problems in writing mathematical proofs? Are you scared when you see equations like this, or maybe even this, or even further this? Well, mathematical proofs are around everywhere. You just cannot escape from it. Be it you're starting your basic mathematics in school level, you're studying geometry, Euclidean geometry, or further up the ladder, you're studying differential geometry, or even topology, or even real analysis, or even complex analysis. Mathematical proofs will surround you wherever you go. So what to do? If we cannot escape from certain things, it is better that we face that thing. By the end of this video, you will gain a great motivation and you will feel yourself comfortable, and most importantly, you will have the required skills to do better mathematical proof. As we cannot escape from something, I am going to give you a guideline how to face that problem, how to develop, write and understand mathematical proofs. Now remember, I am making this video not for a proof based on real analysis or complex analysis or differential geometry or even calculus. No, I am making this as a general video so that anybody who is facing any kind of a mathematical proof can watch this video, get a guideline, get a kind of an understanding, and can further enhance in writing proofs. So what you need to do is right now grab hold of a pen and a paper and note down certain very important things, because this video will improve your ways of understanding mathematical proofs. My name is Shaunak and you're watching this video on my channel Physics for Students. First, let us understand that what is a mathematical proof. So right on your screen you will see one definition which states a rigorous mathematical argument which unequivocally demonstrates the truth of a given proposition. Now you see I have underlined and make it in red, unequivocally. So unequivocally means without any problem, without any further I would say any kind of a circular reference or any kind of an ambiguity. Second, you see on the screen it is written, a mathematical proof is an inferential argument for a mathematical statement showing that the stated assumptions logically guarantee the conclusion. So both of this, unequivocally and logically guaranteeing the conclusion, means that there will be certain conditions which will be given to you and you will have to generate or develop a kind of a mathematical proof. For example, I need to prove that my name is Shaunak. Now what I need to do is that in this room there may be many other people by the name of Shaunak. So I have to develop certain conditions without any ambiguity, without any problem, that my voter ID card or my hair color or my skin color and my physical appearances etc. finally defines that this person is only Shaunak and nobody else. So you see, logically guaranteeing the conclusion. What is the conclusion? Conclusion is that I need to prove that my name is Shaunak. Okay, right on your screen you will see there is another definition which is called proofs employ logic expressed in mathematical symbols along with natural language, which usually admits some ambiguity. In most mathematical literature, proofs are written in terms of rigorous informal logic. So you see that when I was telling that my name is Shaunak, or this is a pen, for example, or this is a mobile, for example, there might be ambiguity, there might be references. So this is a mobile, another mobile is also a mobile. So we need to prove that this mobile is something which carries maybe ABCD features. So you see that in natural language, when we are expressing natural language, there might be certain problems. There might be problems in communication where there is a circular reference that although we mean that this is a mobile which carries this features, yet another mobile also carries this feature. So how will I prove that this mobile is the mobile? Rigorous informal language. What do we mean by rigorous informal language? We will come to that. So that would include symbols, logical quantifiers, and a lot many things. So first of all, we right now understood in this part of the video that what is a mathematical proof. And why do we need a proof? Because without a proof, things would be hayward. Things would have ambiguity. So you say this name is Shaunak, my name is Shaunak, you get another person by the name of Shaunak. You say that the color of the rose is red, but you see there might be another flower which is also named rose, but it is also red. So in order to avoid those ambiguities and to come to a particular conclusion, we need mathematical proofs. The mathematical proofs are also essential in order to give a formal definition of something. By formal, I mean to again say that there is no ambiguity, there are no circular reference, and there are no further problems, and we can certainly define one particular mathematical proposition. Now when I am talking about language, then what do we use in language? We use general English, the way I am talking. But when we use language, what happens is that there are a lot of ideas that we try to communicate, yet we are unable to communicate. So because mathematics is a language, and in proof we are conveying that language, what is the problem, or what are the things that we should be careful of when we are writing about communication? Coming up in the next part of our video. Writing proofs is basically all about communication. We know that mathematics is a language, so definitely writing proofs cannot be something beyond communicating. Now the problem is that whenever we come across a proofs, or in general when you will see those proofs, you will see that it's a page full of lot of symbols, logical quantifiers, and and, not, universal language, all those things. But the fact is that this is the thing that you should keep in your mind, that when you're writing a mathematical proof, you need to write it explicitly. You need to use a lot of English language, because, as of, hence, we know all those things. So the thing is that when we are writing a kind of a proof, especially a proof which is a very rigorous mathematical proof, remember that it is not necessarily that you put all those mathematical quantifiers and symbols only. No, you can put a lot of normal English language, so that proof, when it is given, when you read, or when you are submitting it to some professor or teacher to read, they can also understand that. Yes, definitely there will be logical quantifiers, definitely there will be mathematical symbols, but that is all not. I mean to say, a page which is just full of logical quantifiers and mathematical symbols, it is very difficult, to understand that proof. And not only for the person who is reading, for you also, it is important that you use proper English, and English which you understand, so that the proof is in a better way to communicate. Remember, that is, we are all talking about is communication. Let me give you a very simple and a funny example. Right on your screen, you see there are two options, tea or coffee. Now, in general, when you ask somebody tea or coffee means what? Either tea or you take a coffee. But in mathematics, or is an inclusive language. So there is a joke that tells that a bartender asked a person that, "Sir, do you want a tea or coffee?" And the person replied, "Yes." Now the reason is that tea or coffee or doesn't mean that you exclude one part, but in mathematics it is an inclusive one. So here on your screen you see that I have given something where each of them must be either in A or in B. In other words, elements of A are both in those A and those in B. Whereas on the other hand, when considering a set of A and B, then each of its element must be both in. So that is how, because or is something which is inclusive, that is why. So remember that when you're writing a mathematical proof, the most important thing that you should be aware is about the language that you're using. What is a language in or in mathematics is not the same language in or and that we use in daily life. So this is point number one. Be aware of the mathematical language that you're using. Point number two, coming up right on your screen, you see I have given an example. There are 3 spoons, 4 forks and 4 knives on the table. What fractions of the utensils are forks or knives? Right. So when I say forks or knives, so what we do is that we add up 4 plus 4 plus 8 plus 3. So we mention the fraction as 11 and 8, 11 upon 8. But when I will say that, for example, I will say that what fraction of the utensils are forks and knives? Okay, earlier I told forks or knives, I showed you it is 11 upon 8. But when I say what are the utensils, what are forks and knives, then the answer would be 0. Why? Because no utensil is both fork and knife. Obviously, that no utensils can be both fork and knife, it cannot be. But and tells that, because I cannot just add up, it will finally add into 0. So this is something right on the screen. I have given a note. Be aware about the language that you write and what are the implications of that language. Write it very carefully. So whenever you're writing a mathematical proof, it can be anything. It can be simple Pythagorean proof, it can be differential geometry, it can be class 8-9 level geometry or mathematics also. But remember, what you need to do is that be careful about the language you're using. So fork or knives and fork and knives, you see there is a total difference. The values go from 11 upon 8 to 0. So when we are talking about all about languages, when we talk about communicating mathematical proofs means communicating languages, and I just told you that you need to write proper English and because hence given, so that the proof is very lucid and clear. What comes to our mind is that one word which we very commonly use in language, that is if. Now when we are doing a proof, obviously we say if given a set of equations or conditions are this, then through mathematical induction or deduction we come into this. So question is that this if has got a long and very important implication in writing mathematical proofs. What are the implications of using if? Coming up in the next part of our video. Okay, so when we talk about using if in a kind of a mathematical language, right on your screen I would like to show you this tells that A implies B. Whenever A is accepted, that means B will also be accepted. So when A and B are two statements, saying A, that arrow B indicates whenever A is accepted, then we also accept B. Now the most important is that the direction of the implication should not be mixed. That means when A is true, the B is also accepted, but not the other way round. That doesn't mean that B will also be true and A will also be true. So that means the direction here on your screen, I have shown you the direction of the implication should not be mixed, right? So we should maintain that in which direction or in which way we are moving. Let me give you a quick example. Right on your screen you see it is raining and it is cloudy. So if the first statement is true, so it is second statement is also holds. So what we can tell from this statement, that if the first statement is true, so it is raining, then we automatically accept that it is also cloudy. However, remember, it does not work on the other way round. That means the fact that it is cloudy does not imply it is written it is raining, it is cloudy. So the direction is from here to here, not the other way round. That does not mean that it is cloudy, it will be raining, right? So what I need to notice further is that accepted means doesn't mean true. So if the value is A, B is accepted, right? Accepted doesn't mean that B has to be true. Again, a problem with mathematical language, the problem that we use in general language. So generally when we see that, okay, he has accepted the gift, that means the truth is that he has accepted, and that is what? He has accepted the conditions of life. That means we are giving some kind of a truth. But remember that accepted here doesn't mean that it is true. It is raining, that is true, but that doesn't give a genuine fact that the second statement is true. That is why it is important. We do not know whether they are actually true. We might have a sunny day. That's true. It might be that it is cloudy, yet the sun is coming out. So accepted does not mean it is true. In terms of mathematics as well as in proofs, we should be careful of. Also, we should not mix up the direction. If one condition is true, arrow with the second condition, we should keep in mind that it should be on that direction but not on the other. Now we all understand this, right? We understood what is a proof. We understood that proofs are very important. We also understood that proof is a language, and then we saw what are the the errors which we encountered in writing the proofs, and we should be aware about that. So not is not what we mean, and accepted does not mean it is true. But yet there is one very important question which keeps haunting, I would say, in our mind, that why do we have to take care of those? Or we can say, why writing proofs are so very difficult? This is a question which keeps on haunting, and that is the main purpose of the video, how to make proofs easily. But the question still remains, why writing proofs in mathematics are so difficult? Coming up in the next part of our video. Why writing proof is difficult? I mean to say, this is the central question, and for that we need to find out the solution. Now you see, the problem is that writing proofs, the basic method of writing proofs, is being introduced at a much later part of our education. I mean to say, if you come to real proof-based system, you won't find it during the early years or the formative years of education. That is one most important thing, that when we have grown, when our cup is filled with a lot of mathematics that we know, we come to encounter proof on a much later part of our life. Also, you need to remember that writing proof is something, when we are given the conditions, we need to prove something, and that is basically understanding the abstractness of mathematics. Now, what do we mean by that? Now, say for example, if I move out of mathematics, right, and I want to say that I want to prove that Indian history, I would say Indian history has got multiple culture, its effect around 100 or 200 or 500 years. For example, that Indian culture, Indian history or Indian culture is full of diversity. Now, if I want to prove this statement that Indian culture and Indian history is full of diversity, what I need to do? What I need to do is that I need to go back to history, learn a lot about the multicultures, the invasions that took place during the British, during the Mughals and different times, and what was the effect of that India has got a lot of cultural diversification, the social norms, the political area, the music, the art, literature, all of them have flourished due to whatever ABC the reason. Now you see here what is happening out is that I have to go back a lot into history, and then only we can understand and I can prove that, okay, so these taken can finally prove that India has got a multicultural diversity or culture which has got multiple faces. So you see that even not in mathematics, I am going back to history. Now I want to prove, for example, that the center of Milky Way contains a black hole. You understand the type of mathematics, study, physics, astrophysics that I have to do. So that brings, it is not mathematics only that requires a lot of hard and difficult time and abstractness of mind, etc. in order to do a mathematical proof, be it any discipline. You take geography, you take mathematics, you take astrophysics, you take language, whatever, in order to prove something, you have to do a lot of studies. So that actually gives the answer that why mathematical proofs are difficult. It is not only for mathematics. You are given any subject, you need to prove something, you have to do a lot of study. You have to go through multiple literatures, you have to go to various other things. Another thing is that when you are given a proof, it is not that you really know what is the outcome. So the conclusion is that we have to prove that n equals to 2. For example, I can just take it as an example that I have to prove that n equals to 2. But for that, I have to go back to certain other axioms or certain other abstractness which is generally not coming to our mind. So one is the difficulty that we get to understand proofs on a much later part of our life. Number two is that be it any proof, whether it is mathematics or any other subject, we have to study we have to undergo a lot of definitions, and then only we prove that. So for example, if I take the famous case of Sherlock Holmes, he told to Watson that in order to find out a proof or deduce something, you have to depend upon a lot of raw data. And where are those data coming from? These are the data which is coming from mathematical studies, axioms, principles and whatnot. So that actually gives us a kind of I would say understanding that these are the things that makes proofs difficult. Not only for mathematics but for anything, but what it requires is a kind of an intuition, it's a kind of a different bent of mind that you need to look into a different perspective. You have to think outside the box as well as inside the box so that you can arrive at a conclusive proof. So given this, we now know that why mathematical proofs are difficult. We know what is a proof, we found it what is a language. Now the thing is that what we need to understand right now is that we understood that proofs are difficult. So what are the problems or what are the mistakes that we make when we are undergoing a proof system? So now we will deal in the next part of our video, try to answer this question, that what are the mistakes that we are making, because until and unless we understand those mistakes, we will never find out a solution. What are the mistakes, common mistakes that we make while writing proofs, coming up in the next part of our video. So mistakes you make unknowingly while writing proofs, coming up on your video. Each of them are very important, pay attention. Number one, it is tempting to skip simple steps. Now you see, this is true not only for proofs. When I see my daughter also doing mathematics to various other students, you will just skip the step, right? We can understand that, and that is where you make the mistake. Remember that you are doing a rigorous, hardcore, logical based mathematical proof. You cannot just skip any step. Even if you think that this is right, I would say write down each and every step. And also when you're writing down the steps, use normal English language. So given that x equals to so, we know from the axiom this, if n equals to or greater than equals to 1, so it is quite obvious from this and this. So when you're writing in a proper English language, your understanding becomes better, your proof becomes much more rigid, and if you're making a mistake, you won't, because you're writing down. Second, not enough explanations. This is something which I just now told, that you are not explaining those steps, you're not writing it in proper English. For example, I woke up in the morning and I took a cup of tea, then I went to washroom. So what is happening, that in between maybe I woke up and took a cup of tea is a symbol x equals to 5. You write that, but also within bracket write what it actually means. And this is the problem that most of the students face, and that is why mathematical proof is difficult. You just write the symbols, you just write the logical set theory symbols, and you don't explain it. Third, finding the starting point of the proof sometimes become very difficult. I mean to say, you're given a proof, yet you don't know where to start. And you know why this happens? You don't know where to start. Because you have not read the definitions clearly. Because you're not clear about theorems, because you don't know the axioms. Now for example, I'm taking a basic mathematical rule that when the power bases are different and the powers are the same, and you're given a division, that the powers would do a minus. So m minus n, and then you follow the rest of the exponential part. Now given a proof, you are left absolutely blank. You don't know what to do. Why? Because you have not read the definitions, because you don't remember the definitions. So that is why point number 3, finding the starting point of the proof becomes so very difficult. You're totally blank what to do, because you really have not read the definition. So number 1, request not to skip the tape. However brilliant you are in terms of mathematics, please write down each and every step in a lucid, proper English. Point number 2, not enough explanations. Explain what you are writing. Explain the symbols, or at least explain the line that you have expressed. And third, please do read the definitions, memorize them by heart, so that when you're given a proof, you do not fall into a kind of a totally blank, I don't know what to do. Now these are the 3 things that are very important, that most of the students generally, I would say unintentionally you make it. But another point still remains, that when we are doing that, what is the type of proof we are doing? Because each of the proof, I will make a later video which will be pretty long otherwise, that each of the proof system that I will just show you has its own problems, has its own errors, and how you can overcome the errors. And anyway, that is the second part of the video, but very important for us in order to understand what are the methods of proofs in general. So you see right on the screen, there are certain called direct proof, mathematical induction, proof by contraposition, proof by exhaustion, etc. So I'm not going into details, but why I'm showing you, it will come very important. Say for example, I'm talking of sum of 2 even integers equals an even integer. So this is something which we call as a direct proof. What is a mathematical induction? For example, we will get a base case. For example, prove that this statement holds for 0 or 1. Then we get an induction, that is for some arbitrary natural number n, and we have to prove that it holds for n equals to 1 also. So it is a hypothesis, and then it is called the induction hypothesis, or it is an inductive hypothesis. Given a set of conditions, we are trying to prove. So there are many other proofs in this way we can learn. But why I am telling those things? This is important, which I'm showing you right on the screen. Learn all of them. Now I'm sure most of the students, they will not agree with me. They will skip certain proofs. Okay, I don't need those proofs, but you really need that. And you know, the problem arises when you really don't know when you need. There is a need that you know, maybe for example, combinatorial proof, maybe a probabilistic proof. You need those things. You have skipped that. And when you're given a proof, you are unable to solve it. Why? It is not that you don't know analysis. It is not that you don't have a good brain, but you really don't know what is a combinatorial proof. What is a proof by induction? What is a proof by negation? You really don't know. So if you really don't know what is a proof by induction or anything like that, then how will you solve the problem? So you see, the root lies in understanding. So I would request that you should learn all of them. Learn all of them, solve a little bit of problem, so that whenever there is a mathematical proof given, you know all of them and you don't have any problem plugging in any one proof which will be required at that point of time. Another thing which I think it is not worth mentioning, but anyway, when I am making this video, this one, you should learn what is called a set theory. Now without set theory, whatever level of analysis or mathematical analysis or a proof driven system that you're doing, you are absolutely incompatible, or I would say you are not eligible to do this kind of a proof. I'm sorry if I'm being harsh, but learning set theory is number one. You need to learn it by heart. You need to understand all the symbols. You need to do the mathematics. You need to understand sets, syllogism, everything. Right? So these are certain important things which generally students miss. These are the proofs. Learn the proofs, do the mathematics, understand them, so that the future becomes much more easier. Now these are the things which we just took, that some errors that you generally unintentionally do. But what are the mistakes that, even if you really don't know, I would say, what are the common mistakes that you really make? Mistakes that are very common, but a little bit of exercise, a little bit of awareness can improve yourself or improve your mathematical proof. Coming up in the next part of the video, what are the most common mistakes and how we can take care of them. So in this part of the video, I would be talking about what are the most common mistakes that a student or you make when you are making or understanding analysis or doing a proof-based system, and how you can overcome that. Number one, right on the screen, misunderstanding of definitions. I am very sorry to tell that most of the students, they do not understand the definition. Now remember that when you are given a definition, it is not just that you are given that, but you need to understand that. I will make a separate video, because again, I've got a lot of stuff to share on proof analysis. I will make a separate video on misunderstanding definitions, how it really impacts in your entire learning of mathematical proof. So please do understand the definitions. Understand until you really get it close to your mind that yes, each and every step that is being done is being understood by the definition, because until and unless you understand definition, you cannot move ahead. Number two, right on your screen, not enough words. What do I mean by that? Not enough words. I mean to say, most of the students, you will see that they have got a tendency of writing only mathematical symbols, but again, as I was telling, not writing enough words, not writing proper English. So right on the screen, if you see, it is found that the students are unable to explain the steps in their argument, as if they think that they are not allowed to use words and they are only allowed to use symbols. This is something really awesome. So you are given a mathematical proof, but it is also remembered that mathematics is a language, so you have each and every right to elaborate that proof in normal, plain, literal English. And I can guarantee you, the moment you are expanding that into literal English, you are done. Your problem is solved. Let me give you a very quick and easy example. You see, this is obviously from Wikipedia. I have written that they have written that first assume that root 2 is rational. Where A and B are co-prime, this. If A and B are not co-prime, we remove all common factors, in other words, etc., etc. The next part you will see, we have found that A square is some integer multiplied by 2, therefore A square must be divisible, this. and then therefore we can write. So what you see on the screen, I mean, I'm not teaching you how to prove square root of 2, but the thing is that you need to write in this way. So we have now found that a square is some integer multiplied by 2, therefore a square must be this, from there we get this. So this is the most common thing which I would request all of you to do. Please write words. Please use words in order to understand. Comprehension and understanding, right? Lack of comprehension and understanding. What do I mean by that? That you have really not understand what is being expressed. And this lack of understanding and lack of comprehension again comes that you have not read the proof properly and you have not memorized or understood that definition. The next comes is what is called incorrect steps. Now what do I mean by incorrect steps? See, what happens is that whenever you are given a kind of a mathematical proof, then immediately you go back to the conclusion. Okay, I need to prove this. That is fair enough. You can do that. But what happens is that, if you are not writing down the steps properly, one after the other, then when you come to the conclusion, you will see that conclusion is being concluded, whereas something is missing. Right on the screen, you see I have given a kind of a figure. So what I am trying to tell is that although your argument should start at the beginning and then lead to the final statement, while constructing the proof, you may want to look at the conclusion and imagine how it may be arrived from the hypothesis. You may be able to reverse the steps to go produce a good proof. That is fine. Another idea is to work from both ends, that is from the beginning until the end, and meet somewhere in the middle. So you see that in this figure I have given that you start somewhere and you know the end, and the proof lies somewhere in the middle, right? So until and unless this really happens, you really do not understand, and if you are not writing down the correct steps, then it is a problem. Here on your screen, this is something which commonly happens. Contradiction arguments often have incorrect conclusion. Induction arguments often start at the incorrect point, and the induction hypothesis is often abused. I've taken it from internet, some kind of a very common errors, etc. So this is one which is that are being done. Point number 1 we should be very aware about is misunderstanding definitions. Please do read the definitions. Go to your professor, lecturer, internet, or whatever the stuffs are there, and understand the proofs definition clearly. As soon as you understand the definition, write them on words. Because until you have enough words, just I have shown proving square root of 2 is irrational, you can write it down. Next is lack of understanding and lack of comprehension. If you write them, this problem is solved. And lastly, do not skip down these steps. You can start at the beginning, come at the end, and you can find it somewhere there. But do write the correct steps, step by step, one by one. Now, these are something which I told you what are the common mistakes, or some mistakes that you don't make intentionally, but somehow it happens. But yet the final solution is still waiting for us. What are the ways, or what are the measures, what I need to do as a student in order to improve my proofs? This would be the next part of the video, very important. Okay, here I am going to tell you a few important ones. Number 1 is right on your screen. Learn and understand the definitions. As I told you, I will make a separate video why definition is important in a mathematical proof, but you have to just right now believe me that they are super important, and a priority is number 1. Please understand the definitions. See, right on your screen I have given a kind of a basic figure definition of what is convex. So figure is convex if this is true. Now what happens is that whenever you are given a definition, I am saying what is convex, right? So here on your screen I would like to show you what you need to do. Number 1, read the definition. Number 2, identify what things it is talking about. That means a figure is convex if for every pair of points within the figure, the segment connecting the 2 points lies entirely within the figure. So you read the definition, you identify what actually convex is talking about. Point number 3, generate a test case. That means try to draw something which would show or obey what is being written in the definition, and it would generate something convex. Third is generate a test case. Now what will happen if that test case is not matching with the definition? That means obviously it is not a convex. Are you getting my point? So generating a test case after reading and understanding a definition will immediately give you an understanding the definition is correct. Fourth would be find examples that do not fit with the definition. This is something strange, isn't it? But it really works out. Now if you find something, for example, the color of the rose is red. I found out something which is blue. Automatically we can say, so if this is blue and the definition says the color of the rose is red, that means this definition is true, because the other thing is not true. I mean to say, kind of a proof by contradiction or something, but in the definition itself, understand, find examples that do not fit the definition. So if it is convex, what is that is not convex? So if I see what is not convex, I will understand what is convex, right? And try to generalize the examples. That means you can put in further examples to generalize what is convex, what is the definition. Point number 2, do a sketch work on how your proof will go on. That means you need to write it down. So this, you write it down and make a basic sketch work. I'm not saying the exact proof, but basic sketch work. See what happens to me also, because I am tied up with so many works, college, then teaching, then videos, then my own studies. So I always do a kind of a sketch. So in this week I will be doing this. These are the videos coming up. These are the studies. These are my college work. These are my webinars. All those things. So if you do a sketch, you will always feel that sketch is working right, and you can go ahead. Number 3 is that understand every line that you write. This is super important. That means you're writing anything with a symbol, understand that. And as I told you right from the beginning, that mathematics is a language. So whenever you write, even you can write A with a sign B, A is greater than B. Don't feel shy. You are a learner, we are all learners. So even if you think that these symbols are creating a problems when you are viewing that, write down that, use the English normal in order to make the sign understand. Point number 4 is try to make your proofs easier to follow. I will say some people you will see they make proofs so difficult. You know, they complicate proofs unnecessarily, so it becomes very, very difficult to follow. Make it lucid and simple. Point number 5, begin by outlining what is assumed and what it needs to be proved. If you have seen my first video in real analysis, I have given an example which is called sandwich method. What is a sandwich, right? There is a bread on the top, there is a bread at the middle, at the end, and in between there is some stuffing, right? Either you have chicken, you have veg, capsicum, etc. So begin by outlining what is assumed, that is the top of the bread, and what is proved, that is the end of the bread. In between, like the proofs, that is the stuffing, right? So if you get what is assumed, this part, and what is being proved, this part, as I showed you, the proof lies in between. That is how it does. Point number 6 sounds to be stupid, but it is very important. Read your proof aloud. If it does not make any sense, then you have not got the proof right. So you see that whenever the children or young people are learning, they read out this, they keep on speaking. Why? Because when you have got a proof, and then when you are reading it out, in between suddenly you will see that there is a problem. Oh, I cannot understand this. Why I have written this? This is not going right. And that won't happen if you're reading it in your mind. That would only happen when you're reading it aloud, shout, or you're speaking your voice out. So don't feel shy in doing that. These are scientifically, I would say, tested proofs which will help your mathematical proof journey much more smoother. So when you are done with the proof, read it aloud. May your ear hear that voice, what you are speaking. When you are reading, you will immediately find where is the problem, and you will understand. Lastly, before presenting the proof, you need to remove the initial work, all those lines, etc., because that are meant for you, not for the teacher. not for the person who is seeing. Yes, you can put up certain lines. What you will put up, I will put up in a separate part of a second video, that how you will write a kind of a neat, clear proof that you score 100 out of 100. So remove those lines and give the answer, submit that what is necessary. So here is a time I would like to kind of summarize these 7 points, because these are, I told you, read the definition, identify what things it means, generate a test case and see something which does not match with the definition. Do a kind of a sketch work, write it, draw it, something like that. Understand every line that you write. Please make sure that you are understanding every line that you write. To make your proofs, make it simple and easier to follow. Begin by outlining what is assumed, what is need to prove, and read aloud when you're reading the proof. And finally, before submitting, remove those which are unnecessary. All for today's video. I just wanted to give you a summary that this is a kind of, I understand, a lengthy video, but this video I think would give you a basic understanding of writing mathematical proofs, general. It can be topology, geometry, differential geometry, calculus, doesn't matter. So the most important thing which lies is practice, practice and practice. Number 1, understanding the definitions very clearly. Number 2, find the end part what you want and go to the beginning part, that is important. Understand all the different type of proofs. Please do not skip any proof, because you really don't know what you really want and what is required after that. Do a kind of a sketch work. Understand the definitions more clearly and try to find out that what does not match with that, so that understanding becomes easier. So you see that we understand the beauty of light when we undergo darkness, right? So that is very important. Also, do not skip those steps. If you are smart enough to do that, don't do this. So I hope this video has been useful to you. I will be making more videos, because I feel 2 things are important in mathematics. One is abstract visualization and writing proofs. And if you master 2 of them, you are a master of mathematics. Thank you for watching this video. Please do put up your comment, and please do subscribe to my channel Physics for Students, and click on the bell icon to get all the notification from Physics for Students. This is Shaunak signing off from today's video on how to develop mathematical proofs. I hope this has been useful, and I will wait for your comments. Coming up very soon with more videos on making mathematical proof super easy for you. Thank you for watching this video.
Thank you for watching this video. We appreciate your time and patience. If you want to connect with us and provide further feedback, comment or suggestions, please email us at contact.physicsforstudents@gmail.com. You can also follow us on Facebook, Instagram and LinkedIn. See you soon in the next video.